Thank you for joining this lesson. We are going to do a physics lesson whereby we respond to a question on forces, and we are given that the figure below shows drops of mercury and water on a glass surface. Explain the difference in the shapes of the drops. So with mercury here and water on the other side, we can see that the mercury drop is spherical while the water drop has already flattened, or it's taking a different shape. It is changing the shape. It dropped here when it was spherical, but now we can see the shape is not spherical. It is spreading. That is the word we can use. So we can say that there are two forces in place here. We have what we call cohesive forces. We have force of cohesion and force of adhesion. Cohesion is the force between molecules of the same kind, while adhesion is the force of attraction between molecules of different kind. So, mercury molecules are attracted to themselves by what we call cohesive forces, but mercury molecules are attracted to the table, the glass table, by adhesive forces. Similarly to water, water is attracted to itself. The molecules of water are attracted to themselves by cohesive forces, while to the table, they are attracted by adhesive forces. So what we can compare here is the strength of these different forces and say that in mercury, the cohesive or the cohesion between the mercury molecules is greater or stronger than the adhesion between the mercury molecules and the glass table, or simply the glass. Therefore, now that mercury is attracted stronger to itself than to the table, then we say the drops have to remain spherical. The molecule drop has to remain spherical because the force attracting the molecules to themselves together is very strong as opposed to the one attracting the molecules to the glass. So we say hence the drop remains spherical. Hence the drop remains spherical. On the other side now, in the water, so we can say in water, the cohesive forces or the cohesion is weaker. The cohesion is weaker between the water molecules. Than the adhesion. Between the water molecules and the glass or end glass. Hence, the drop spreads. So what is happening here is that now, in water molecules, the force attracting water molecules to the table is stronger than the force which is attracting water molecules to themselves. Therefore, the water molecules are more attracted to the glass than to themselves. This is the glass. So, the water molecules are more attracted to the glass than to to themselves. And that means now they have to spread on the grass, because that is where they are attracted more. Let's get to another question here on horizontal projection, linear motion. We are told that a ball is thrown from the top of a cliff 20 meters high with a horizontal velocity of 10 meters per second. Calculate the distance from the foot of the cliff to where the ball strikes the ground. So we know that for horizontal projection, if an object is thrown from a certain height, for example here we have 20 meters, and it is being thrown with a horizontal velocity, which we've been told it is 10 meters per second, then this ball has to move and eventually come back to the ground. Now, before getting to the ground, we say that it has covered a certain distance called range, and range is calculated by ut. So if range is ut, then we first of all have to get the distance taken in this motion, and we usually say that the height itself is given by half gt squared. Therefore, we can get the time in this motion, whereby we say 20 is equal to half acceleration due to gravity times 10 times t squared. So this is 5, and when we divide through by 5, we get t squared as 4, which means t is 2 seconds. So if we have time as 2 seconds, and we know that the range which the ball has to cover before hitting the ground then is given by u times t, we can substitute u as 10 and t as 2 seconds, and this will take us to 20 meters horizontally. So this is the horizontal distance covered before the ball comes to the ground. Thank you for following. Please ensure you subscribe to this channel and share the link with your friends. Thank you.